We are comparing volume of water tanks. So this is probably referring to cylinders. Most water tanks are in the form of cylinders. But let's go ahead and look through it and see what we can do. We have two containers designed to hold water are side by side, both in the shape of a cylinder. Yes, container A has a radius of 9 feet, height of 13 feet. Container B has a radius of 6 feet, height of 19 feet. Container A is full of water, and the water is pumped. Into container B until container B is completely full. Okay. To the nearest tenth. So we take our answer around to the tenth place when we're done. What is the percent of container A? What is the percent of container A that is full after pumping is complete? Okay, so let's see what we got here. We want to show question. All right. So here's a little demonstration of what it is. All right. We'll play. All right. Doesn't look like it's playing, but it looks like here's our container A. It gets pumped and goes into container B and then fills up container B. And then there's just a little bit left in container A. And then we're asked, what is the percent that is full? Okay. So let's go ahead and attack it. As always, I would recommend just drawing your cylinders. All right, that looks pretty good. All right, there we go. And this would be, I'll call this A. And what's the other one called? B. And on A, radius of 9. So there's our radius. R equals 9 on A. And height of 13. So that's height of A and radius of A. And on B has a radius of 6. So R is equal to 6 here, and that's B, RB, sub B. And the height, so H sub B, is equal to 19. All right. That should be everything we need. And we're talking about volume here. So what's the volume of a cylinder? Volume is equal to the area of the base. It's a circle, so that's pi r squared, and then times the height. So we fill it up with that height. All right, so it looks like we got everything we need. And we'll go ahead and calculate the volume of each one of these and then use the action that happens here to get through the problem. So let's go ahead and start with volume of tank A. I'm using capital A here. Let's make sure everything matches. Volume of tank A is equal to pi r squared. R is 9 for tank A. And the height is 13. And calculating that, that would be equal to pi times 81 times 13. 81 times 13. Uh, 1,053. $1,053 pi. Okay. And not sure how to keep these numbers going because we're going to have some action going on with these, and we'll do our best to get through it. So we'll just keep going. All right. So this is in, I'll deal with the pies. Yeah. So that's going to be the key, is we'll keep pi going until we finish everything, and then we can round. Okay. That sounds like a good plan. All right. Then we'll go ahead and look at the volume of tank B. So give myself some more room here. Okay. Volume of tank B is going to be equal to pi times the radius squared is, radius is 6, times the height, which is 19. It's going to be equal to 36 times 19 and 36 times, let's go ahead and clear, 36 times 19. 684. We still have that pi. All right, good. So from tank A, it gets pumped in to tank B and fills it up. And then we have some liquid left that's still in tank A. And then we want the percentage of what's left. Okay. So hopefully you can kind of see what's going on here, is that the 684 is getting taken away from the 1053, and we're talking about in terms of pi. So all of this is going out until this gets filled up, and then it stops and there's some left over. So that's 1053 pi. So now we're going into the process of pumping it out, minus the 684 pi is going to give us what's left. So that's 1053 minus 684. $1053 minus 684. And the reason why I don't have pi in here is I just put it at the end. These are both in terms of pi, so we're basically combining like terms. 1053 minus 684. Okay. 369. So this is 369 pi for our volume of the A tank minus the B tank. Okay, so that's how much water is left in here. In tank A is 369 pi units cubed. And then the last thing that we need to do is make it into a percent. Okay, so a percent is out of the whole. How much is left out of the whole? So we would take our 369 pi divided by the whole. And what is tank A's whole? Tank A is 1053 pi. Okay, so pi is reduced, so it's 369 divided by 1053. 369, oh, delete. 369 divided by 1053. 369. So I got 0.3504. 0.3504. So all this is equal to 0.3504 ... and nearest tenth. So that's a tenth of a percent. Okay, so percentages means that this is 0.35, and it basically we're just bouncing the decimal twice. So this is now equal to, this implies that our percent volume is going to be equal to 35.04 ... percent and we want a tenths place. So that's the tenths place. We look at that number there. It's a 4 or less, so everything drops off. All that turns into our percent of volume that's left over is now approximately equal to 35%. Let's see how we did. 35%. Got it. Okay, so let's just go ahead and look through our work, see how they did it compared to ours. Volume of container A, I really recommend keep it in terms of pi. So that's going to keep your work a lot easier, and you're going to avoid these infinite decimals that are going to pop out. Keep pi also in here, not what they're doing. Let's see if this video will work. There we go, and that's what's happening here. And then there's the logic that they're using. They have it as a divide by a 100. For me, I just multiply it by 100 at the end and keep it as a percent. Good. Okay. So the different problem types. That was the percent of the tank that is full, the percent of the tank that is empty. So we can, for that one, it would just be an extra step of making sure that we're looking at the emptiness of the tank, not how much it's full. So that's probably just what's left subtracted from the full tank, and that'll give us how much is empty, divided by the 100%, that'll give us the percent. Volume of empty space and volume of water. So those were the easier ones to kind of deal with. All right, so it looks like that's a good start to getting through these.